Hello, in this discussion we'll be talking about the modeling and solving applied problems involving right triangles. So the dreaded word problems. So we're going to begin with a piece of metal, and it's 12 inches long, and we're going to bend it up as such on the bottom picture. So the thetas are on the bottom. So we have a rain gutter. It's got 12 inches wide. After marking off a length of 4 inches from each side edge, the length is bent up at an angle of theta. So see the picture at the bottom. Alrighty. So remember the bottom's 4 inches and the two sides of the gutter are 4 inches because we have a 12-inch gutter wide. Alrighty. So that's got the idea. So what we want to do is express the area of the opening as a function of theta. Alrighty. Now, if you don't want to use theta, you can actually find the area by conventional means. If you notice, in the inside, we have a rectangle where it's got 4 inches on the bottom, and then it goes up B units. So how do you find the area of this whole gutter with just using geometry? Is find the area of the rectangle, which is 4 times B. Okay, and that's the bottom. And then the two triangles on the side. Well, how do you find the area of a triangle is 1/2 base times height. Well, these triangles are going to be on their side, so the base is still the B, and the height of this each individual little triangle is A. So it's 1/2 AB, but there's two of them. So it's going to be one on each corner. So if you look at the formula for this, area is going to be 4B, which is the area of the rectangle, plus 2 times 1/2 AB. Now, the reason it's 2 times because there's two individual triangles, and 1/2 AB is the area of each of the two triangles. B is its base, and A is its height of each individual triangle. So do the math, clean that up a little bit, and that's going to be 4B times AB. Plus AB. So 4B plus AB, because we're going to add those up. We're going to find the area of the rectangle plus the area of the two triangles. So it's 4B plus AB. All right. Now, we know sine of theta is going to be B over 4 because looking at the triangle, it's a right triangle, and theta is the one in the upper right-hand corner of the gutter, and the opposite side to theta is going to be B, and the hypotenuse is that part of the gutter, which is the hypotenuse, and that's B over 4 then. So solving for B, we have 4 times the sine of theta. And you might ask, well, why are we wanting to know what B is in terms of theta? Because the original problem, what they want me to do, express the area of the opening as a function of theta. Now, the first line that I wrote up there, 4B plus AB, is not in terms of theta. So those that 4B and that AB that follows it, I need to rewrite those in terms of theta. So one of the things I'm going to do eventually is take those B's in that original equation and replace it with 4 times the sine of theta. And there's 2 B's up there. And then I'm going to do a cosine of theta, which is going to be A over 4. And you're like, why do I need to know this one? Because in the original formula, it has 4B plus AB. So I need to get rid of that A too. So sine of theta equals theta divided by 4, A divided by 4. And so A is equals to 4 cosine of theta. So what I'm going to do is take those two values and replace it in the original area formula. So area is 4B plus AB. Now replace. So it's 4 times the sine of theta plus 4 times cosine of theta times 4 sine of theta. Do the math and simplify it out, and that's what you get. Okay? So it's going to be 16 times the sine of theta, parentheses 1 plus cosine of theta after you factor it all out. And so that gives you the formula. Okay, so that takes care of A. We have a formula to find the area. So what you got going on here, guys, is if you can find the area of this gutter now, and all you have to know is that theta has how much you bent it up. So if you know the angle that you bent it up, if you know that angle is, say, 20 degrees, So if you know that angle is 20 degrees, then you can just put 20 degrees in there and it'll tell you what the area of that inside gutter, which is pretty cool. So you don't need to know anything else. You don't need to know the A and you don't need to know the B. You just need to know what theta is. And again, this is, does that work on every gutter? No, because this is a gutter that's 12 inches from end to end of a metal. So if you change that to 18 inches instead of 12 inches, your numbers are going to be different. So, but in this case, if you know theta, in other words, the amount that you bent the metal up, and then plug that into this formula, it'll tell you how much water that you can flow in a certain cross section of this gutter. All right, let's go on. All right, so the next thing what we're going to do is going to find the area of the opening for different angles. We're going to see how much water could flow through a certain cross section at 30 degrees, 45 degrees, 60 degrees, and 75 degrees. So at the 30 degree one, area at 30 degrees, you plug that in, and it turns out to be 16 times the sine of 30 degrees plus times 1 plus the cosine of 30 degrees, which turns out to be 8 plus, I believe, 8 plus 4 radical 3. And you want to know what that is as a decimal? Be my guest. So you just pop that into a calculator, 8 plus 4 radical 3, and that'll tell you how much that is. Now the next one, the area at 60 degrees, it's 45 degrees is our next one. So we plug that in and do the math, and we get 8 square root of 2 plus 8. All right? So it's just a matter of calculation. Notice the angles that they're giving you are nice angles. Angles that we don't really need to use a calculator for. They're special angles. 30 degrees and 45 degrees. Not really necessary for them to do that. I mean, they could have given you a 50 degree angle too. You could bend that thing up 50 degrees. In that case, you'd have to use a calculator because you wouldn't get an exact answer, but you could still use a calculator. So, but in this case, they're trying to let you see that you're going to do this without without using a calculator, and you can get these exact answers. Okay, now let's try the 60 degree one. So same thing, put in the 60 degrees in there, and that's going to be 12 square root of 3. All right, so 12 square root of 3. And this time I went ahead and wrote it as a decimal. I went in and got my calculator out, and I got 20.78. That's the area. That's the area in whatever it is in inches, I guess. Yeah, it was 12. It was 12-inch wide metal, so it's going to be 20.78 square inches in that cross section. 20.78. Now I did another one at 75 degrees. Did the math and everything else. And again, now this one is not special. Notice it's not 30, not 45, not 60. In our previous videos, we've learned that these are the 3 special angles that we have so far. There's more coming, but 75 degrees right now is not one of them. So you would have to definitely use a calculator to figure out this value. And if you do, it's going to be 19.4. All righty? Now, I want you to notice something here. Look at the answer to C and look at the answer to the last 2 problems. The area of the 60 degree one and the area of the 75 degree one. I want you to notice with these numbers, the area actually went down from 20 down to 19 something and some, because when you bent it up too far, it didn't allow as much water to flow through it. So the question becomes is, well, what angle would probably be a good idea in order to figure out the most area that can come through? In other words, if you're going to be the manufacturer of this and everything, where should you stop where should you bend it? How far should you bend it up to get the most area through there? So because you want more water to come through as much as possible, and that's the question we might have. And so it says what we're going to do is we're going to graph that function in terms of theta. So we're going to find the angle that makes A the largest. Okay, so what we're going to do now, remember the formula. Let's go back and look at that formula real quick. Okay, there it is. It was that last one. There it is. It's going to be 16 times the sine of theta times 1 plus cosine of theta. So that's the one we're going to graph. All righty? All right. So they graphed that. And I want you to look at what the theta had to be. Because look at the parabola. It's kind of an upward parabola that's coming back down. And the highest point there is where the highest area is going to be. So that theta had to be just a tad bit over 60. But notice the area that went through there, 20.78. Now I will tell you, you won't see anything like this on your exams because it does require a graphing calculator. But I thought it was worth it to show you what this was about. So between the 30, the 45, the 60, and the 75, if you remember, I did the 60-degree one, and it was 20.78 in that previous slide. And so that would be the place you would need to bend it to. If you bend it too much, if you bend it up to 75, you won't get as much water to go through it. If you bend it at 45 degrees, that would have been too low. And so at 60 degrees, it gives you the most area that you could possibly get. So it's a pretty neat thing if you're a company who is building gutters, because they have these metal slides and they want to know, we want the most water to be able to flow through this. And this is kind of how they would do it. And they would say, okay, we need to bend this thing up about 60 degrees to get the most water through this. If they want the base and the two sides to be the same, 4, 4, and 4. So they would need to bend those sides up 60 degrees. So this is kind of where you could use trigonometry in real life. So, all right. So the area is 16 plus that, and then that gives you that's the formula we're using. I didn't have to scroll back to find out. Actually, I forgot I put it here. So 16 times the sine of theta times the 1 plus cosine of theta. All righty? Now, I'm going to show you, or at least talk to you, about this next problem here. Yeah, I think I'll go ahead and do it. I think we did this one too. A surveyor can measure the width of a river by setting up a transit. And a transit is something that you can measure angles with. You see if what angle things are, if something is level or not. So that's what a transit is. So at a point C on one side of the river. So that C is where that right triangle is at. Okay, and of the river, and taking a siding of a point A on the other side. So basically they found, maybe it's where A is at, maybe there's a tree right there, I don't know, something's on the other side. And so refer to figure 37. Okay, after turning through an angle of 90 degrees at C, the surveyor walks a distance along the bank of 100 meters, as the picture indicates, to point B. And then he uses his transit to find what that angle is going to be to where A is at. And then once he found that angle, he measures it, and it looks like it's around 30 degrees. All right? What is the width of the river rounded to the nearest meter? So maybe that river is really wide and you can't cross it. You want to know how wide the river is at that point. So if you have a transit with you, you could actually figure out how wide the river is without actually measuring it. Of course, you need a little bit of equipment. You need a transit to figure out what that angle is, theta in this case. So, is that beta? That's beta actually. So beta is 30 degrees. Now, let's look at how to do that. Well, the tangent of the beta, tangent of 30 degrees, remember, is the opposite side of that triangle, which is the width of the river. That's B, over 100, which is the adjacent side. And so B is 100 times the tangent of 30 degrees. So it's solving for B. That's what we get. And then it's 57.73 meters. So the width of the river at that from C to A is 57, just under 58 meters. So you can actually find the width of a river without actually crossing it. Yeah, but of course you'll need a transit to do it. So to figure out what that angle is. All righty. Now let's talk about a couple of things here, just kind of giving you some vocabulary. What does angle of elevation mean, and what does the angle of depression mean? What do those terminology mean? The angle of elevation is from the horizontal to the line of sight when the line of sight of the object is above your head. So you have to elevate your head in order to see the object. That's going to be the angle of elevation. If you have to lower your head or depress your head, like the second picture indicates, that's called the angle of depression from the horizontal. So you have the horizontal and you have to lower your head to see the hat. And so you had to lower that, and so that's called the angle of depression. Again, this is just vocabulary that you're going to need on some of the application problems. All right, so meteorologists, okay, find the height of a cloud using an instrument called a ceilometer. What is that called? Ceilometer, yeah. So a ceilometer consists of a light projector that directs a vertical light beam up to the cloud base, and a light deflector that scans the cloud to detect the light beam. See the picture, okay? So on December the 1st, 2004, at Midway Airport in Chicago, a collector with a base of 300 feet was employed to find the height of the cloud cover. If the angle of elevation of the light detector is 75 degrees, that's your theta looks like, what is the height of the cloud cover? So again, it's very similar. It creates a right triangle there. The base is B, the height is that H, and remember they said the base there is going to be 300 feet. So the ceilometer is going to be 300 feet from the light projector. Okay. All righty. There we go. So now we got the tangent 75 degrees is, remember, it's opposite over adjacent, height of the cloud cover divided by the base. So the height would be the base times the height of, times the tangent of 75 degrees. So then it's just a matter of plugging in the 300 for the base. So 300 times the tangent of 75 degrees. And since tangent 75 degrees is not one of our special angles of 30, 45, or 60, I definitely have to use a calculator. And it gives you 1,119.7 feet rounded to the nearest tenth of a foot. Now, a lot of these applications, you're going to have to round. You're going to have to round these things. If they don't tell you how, I would round at least to one decimal place. Typically, they'll tell you though how far to round it. It's kind of, if they don't tell you, kind of for me is default to the tens place. So if you have any questions, well, let's do one. Let's talk about another one here. Find the height of a statue of a building. Okay, so what we're going to do here is we're going to look at the top of a board trade building in Chicago is a statue. They call it Ceres, the Roman goddess of wheat. Okay, from street level, 2 observations are taken 400 feet from the center of the building. The angle of elevation to the top of the statue is 56.5 degrees. Now, what is the height of the statue? Now, so basically to the top of the head of the statue, it's 56.5 degrees. But to the top of the building, it's only 55.1 degrees. So how do you think we're going to do this? Well, first of all, let me tell you, this is yours, but I'm going to give you some hints, okay? What you will do, you will need to find the height from the ground up to the top of the statue's head. So what you would do is you would use your tangent function. And your tangent of 56.5 degrees is equals to that height divided by 400. Okay, because the width is 400 feet. So then you find out what that height is. Then you'll use the other angle, tangent of 55.1 degrees, and do its opposite over adjacent. But in this case, the opposite is just the height of the building. The adjacent is still 400 though. So then you'll find the height of the building. But remember the first equation, you found the height all the way up to the top of the head of the statue. So when you find those heights, what do you do at the very end? Well, the first one's going to have a lot higher height because the head is far taller than the building is. So the difference of those two heights is the height of the statue. Because the first one, when you do the tangent of 56.5 degrees, equals the height of the statue to the ground divided by 400, okay? That's going to be more than the next one. And so the difference is that will be just whatever the height of the statue is. So, but I'm going to leave that one up to you. So if you have any questions on this one, feel free to contact me. And I know applications always cause some trouble, but if you have questions anywhere, this is probably going to be the place. So, and you have a good day.